In the previous video, we discussed on gravitation and we learned that it is an attractive force between any two objects. And this force is not easily detectable in a small object but can be detected only in a large object like the stars, planets and other heavenly bodies. But how do we measure this force? To understand this, we have to understand a simple law, and the law is called Newton's universal law of gravitation. To understand this law, let us suppose that there are two objects A and B. Let me draw the object A. Let it be object A, and we have another object here B. There are two objects. This is the center of the object A, center of the object B, and when we join these two centers we get the distance between the center of A and B. Let the distance be, it could be 10 meter, 20 meter, 10 centimeter, 20 centimeter, 100 meter, 100 kilometer, whatever. So we denote the distance by D. And let us assume that the mass of A be m1 and the mass of B be m2. And the law says, that is the universal law of gravitation says that the force of attraction between any two objects is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Okay, I repeat the law once again. Newton's law of gravitation says the force of attraction between two objects is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. So we have two objects here, object A and object B, and the mass of object A is m1 and the mass of B is m2. M1 could be anything. It could be 10 kg, 20 kg, 30 kg, 1000 kg, whatever. Or 1 gram, 2 gram, 3 gram, whatever. M2 could be, it's a mass, so it could be 10, 20, 30, 40 kg. And D denotes distance, so it could be 1 meter, 2 meter, 3 meter, 4 meter, whatever. So we have just supposed M1 to be the mass of this object A and M2 be the mass of the object B and D to be the distance between their centers. Now we will break the law into two parts. The first part, the force of attraction between two objects is directly proportional to the product of their masses. It means the force of attraction, first part, is directly proportional to the product of the masses of the two objects A and B, that is m1 times m2. From the first part we get this relation, and let's go to the second part. And the second part says, and inversely proportional to the square of the distance between their centers. That means force of attraction is inversely proportional to the square of the distance between their centers. So these are the two relations we get from the Newton's law of gravitation. So now we will move on to the next part, that is to prove F equals to Z m1 m2 upon d square using Newton's law of gravitation. Okay, Now to prove F equals to G m1 times m2 upon d square, that is force of attraction or gravitation is equals to the product of m1 m2 upon d square. Here G is a gravitational constant, so we will prove this, but before that we will break Newton's law of gravitation into two parts. That is, the first part is the force of attraction between two objects is directly proportional to the product of their masses. That is, in mathematical form it can be written as force of attraction is directly proportional to the product of the masses, two masses, that is m1 times m2. We get equation 1 from here. And the next part says the force of attraction between two objects is inversely proportional to the square of the distance between their centers. So in mathematical form it can be written as force of attraction is inversely proportional. When we say inversely, we write it 1 upon this square. That is, force of attraction is inversely proportional to 1 upon square of the distance between their centers. This is equation number 2. So here the force of attraction is directly proportional to the product of the masses. That is, if the product of the mass increases, the force also increases. If the product decreases, the force also decreases. That's why they are directly proportional. But in this case, in the second part, if the distance increases, the force decreases because they are inversely proportional. So if the distance decreases, then the force increases. That's why force of attraction and the distance are inversely proportional. Now combining equation 1 and 2, we get combining equation 1 and 2, we get force is directly proportional to the product of the masses and inversely proportional to the square of the distance between their centers. And now we change the proportionality sign into equality sign, and here comes a constant. This G is called gravitational constant. Here G is gravitational constant.